we introduced GenNBV, a generalizable next best view prediction policy for active 3D reconstruction. Previous works on active 3D reconstruction face some challenges. For example, in this work, the algorithm only works for cameras with limited movement space, so it is not easy to apply it to larger objects like buildings. Also, they need a predefined action space for each target, such as a hemisphere. This cannot ensure sufficient coverage for complex targets with self-occlusions, preventing them to generalize to unseen targets. Therefore, in this work, we propose a novel solution that allows a free space and a comprehensive scanning for buildings. And it can also generalize to unseen objects. To achieve that, we first design a reinforced learning policy that allows a genetic 5 degree of freedom movement. So our agent drone can capture self-occluded details. Then, at each step, the drone first captures multisensory data, including RGB images and the depth maps, which are then encoded as state embedding and later sent to the policy network to predict the next pose. Here we show the process of active 3D reconstruction. The drone captures the visual observations with the initial viewpoint, reconstruct a target, and predict the next best viewpoint. We repeat this process until the scanning is finished. Moreover, our policy is trained on hundreds of objects and can generalize to unseen buildings. Here is an overview of our policy network. To train the network, a reward signal that encourages the drone to increase the coverage ratio will be returned at training time. We train our policy on hundreds of objects from houses 3K. It can generalize to unseen objects from houses 3K, omni-objects 3D, and observers. Here are comparisons. Compared to baselines, our GenNBV captures more details and achieves the best coverage ratio. Here are more comparisons. Here are quantitative comparisons on houses, as well as other objects. Our ablation studies also demonstrated the effectiveness and the generalization ability of the proposed approach. Thanks for watching. More details are presented in our website.